Okay, so triangle proportionality theorem. This is from lesson 12.1 in your text. Your essential question: when a line parallel to one side of a triangle intersects the other two sides, how does it divide those sides? Your learning goal today: I can apply the triangle proportionality theorem. All right, so our vocabulary slide here, I don't have any new terms specifically to define for you. So we're going to jump right into what this triangle proportionality theorem is. So we have words to explain it, what the theorem is. We have a picture, and then we also have the conclusion, which is the proportion that it creates. So I'm going to look at the picture first here with you guys. You can see we have a triangle. Triangles have three sides, of course. And there's one side of the triangle that has this arrow right in the middle of it, and then there is a line intersecting the triangle through the other two sides that doesn't have the arrow, and that one does have an arrow. So this means that these two lines are parallel. So segment EF from E to F is parallel to, that's what these two lines next to each other mean, to segment BC, or side BC, okay? They're parallel. When that happens, and this is cutting these other two sides into two pieces, well, it creates a proportion. And so if a parallel line to a side of a triangle intersects the other two sides, and that's what is shown here, then it divides those sides proportionally, which means that I can write a ratio. I could write a few different ratios, but the one that we're going to use as our general version is AE. Okay, so that's this top segment above where it's intersecting on the left is proportional to EB, this segment here on the left below the intersecting point. And that is equal to, proportional to, AF, the top segment here, FC, this segment here. So by this theorem, we can find out missing segment lengths if we know that there is an existing proportionality between those segments. So here we are on our third slide already, halfway through. Applying the triangle proportionality theorem. And so this is an example where we can use it to find the length of a segment. The segment we are going to find is the length of CY. And so if I come over here and look at the picture, there is in fact a triangle, ABC, the large triangle, and there is a segment, okay, inside of it, XY, which makes this segment here is actually parallel to the bottom of the triangle BC. Right, so these two lines here, these line segments are parallel. And when they're parallel, okay, it is given that they're parallel, it creates this proportion by the triangle proportionality theorem. All right, and so it's just like on the last slide, except, we're looking at a different side of the triangle now, and it works for any of the three sides of the triangle as long as you have one side parallel to a segment that passes through the other two sides. So there's three possibilities since there's three sides to a triangle. And so the segment AX right here is proportional to, that's the numerator of our ratio, to XB right here. So 9/4. And that is equivalent to, proportional to AY, okay, the top part here, this length of 10, over YC, this unknown length here. So we can figure out CY, which is what it's asking us to find, just by substituting the three known values into this proportion. So we replace AX with 9, we replace XB with 4, we replace AY with 10, and then CY is the unknown length. And now this is something that we can solve with algebra. Whenever you're solving a proportion and your variable is in the denominator, one way to tackle that issue is to take the reciprocal of both sides. So that means it's absolutely mathematically legal to take 9/4 and take the reciprocal as 4/9, and also take 10 over cy and change it to its reciprocal of cy over 10. This is totally acceptable. That's not the only way to solve this, but this is how they're showing you how to solve it here. And so once you're at this point, we can solve for cy. Since cy is being divided by 10, we do the inverse operation. We multiply by 10 on the right and multiply by 10 on the left. Okay, so that's what we have here. And then, yeah, reciprocal both sides. And, you know, for myself, like, I really haven't seen that as a technique very often, but it is true that you can do that. And you don't have to do that. When you solve things with algebra, as long as you follow the rules of algebra, you're good to go. Like if I was solving this and not just following along with an example, I might do cross multiplication and do like 9 times cy and get that on one side, and then 4 times 10 and get 40 on one side, and then divide to get 40 over 9 that equals cy. So there's different ways to solve this and get to this point here where cy is equal to 40 over 9. So if you don't like taking the reciprocal of both sides, you don't have to do that. That's just the method they're showing you here. Okay. But it does work out. And so simplifying this, we get 40 over 9 is cy. And then this is an improper fraction where our numerator is larger than the denominator. And so we can change it into a mixed number by dividing the denominator into the numerator. 9 goes into 40 4 times evenly with a remainder of 4. That's the new numerator, and then the denominator stays the same. So both of these are acceptable ways of writing this length here, cy. And you should always check for whenever you solve for a missing side length. So we figured out this is 4 4/9 right here. And that should make some sort of sense, okay? So if you look at the picture and you can see the segment across from it is 4, and then these are the shorter ones and these are longer. This is 9 and 10. So, I mean, it makes sense that this would be something right around 4. You know, if you ended up with something like 49 as your answer, you probably made a mistake. So you should always check that your answer makes some sort of sense with the picture that they give you. Pictures can be deceiving. I'm not saying it has to, don't use the picture, but just use it to gauge your answer that maybe you maybe made a mistake or you did something correct. Hope that makes sense. Okay, so we are going to do an example together now. And so at this point, it'd be probably pretty useful if you can have your Google Meet window on half of your screen and then have your Pear Deck window on the other half of your screen side by side. Remember, you can just pull a tab out by dragging it out and then resizing it. You can move it around your screen however you would want it to look. Okay. We're going to use a lot of color coding here to kind of help you see where this proportion is coming from, because we're going to apply the triangle proportionality theorem and find Pn. So this is our unknown. I'm going to use the line tool, and I'm going to change the size to the smallest size. So this is our unknown, Pn, the segment. I want to know how long that is. And if I come over here to the picture, I'm going to create, I'm just going to color it the same color that I have so far. So go ahead and do that. We're going to color code this whole thing. It's going to be like a rainbow when we're all done with it because there's so many segments. And if you look at this picture, you can see there is a triangle, MLN, okay, the big triangle. And there is a pair of parallel segments, okay? LM is parallel to PQ. And it says that. It is given that PQ is parallel to LM. You can see that from the picture, okay? That's what those little arrows mean. It means those line segments are parallel. And so I'm going to use another color. Let's use something like yellow. I'm actually going to make both of these yellow because they're both parallel. We're not trying to find these lengths, but I am going to highlight them just to show you that we have that pair of parallel segments okay? And you need that in order to use the triangle proportionality theorem. Once you have this, where a side of the triangle is parallel to something intersecting the other two sides, then we can write our proportion. So here I am again with colors. NQ, which is here, is in the numerator to the ratio over QM, which is here. All right, and this is what we were doing before. We were taking the piece above where the two parallel lines are on one side and putting it over the other piece on the same side, which was in between the two parallel segments. Okay, so 5 over 2, or NQ over QM, which we have here, 5 over 2. And then we're going to write the other half of this ratio, I'm sorry, of this proportion. So here's my fraction bar, and I need to put something in the numerator and something in the denominator. All right, and so just going off of our theorem, you know, we want to put this blue segment, PN, we're going to put this in the numerator. So then I'm going to grab the text tool here. And type PN. And I am going to color code it too. So I'm just, nope. Okay. That's going over the segment. Well, the one we haven't used yet, this smaller segment on the side, that's the same side with PN in between the two parallel lines. PL. I mean, technically you want to have to put these line segment things here, but I'm just putting them there because I'm trying to color code it. All right. If you're just writing it, you might just write, ooh, that's way too thick. There we go. Okay. You could also just write it as NQ over QM is equal to PN over PL. Right? So you don't have to put these little bars here. I'm doing that just to kind of show you where it's coming from with like probably way too much color coding, but that's how I roll. Okay, so that's the triangle proportionality theorem. And now we're going to substitute out. We got to substitute, you can see 5, 2, and 3 are going in places for these things here. Right? So what do we substitute for NQ? What should we put for NQ? NQ, how long is that segment, NQ? You could type it in the chat.
It's a 5.
It's a 5, yeah. So we're going to put a 5. Not liking me. There we go, 5. And then what are we going to substitute for QM? QM. 2, good. Awesome. And then 3 is going to be replacing what 2 letters? Yes, PL. Try to be consistent with coloring. There we go. All right. So now that we know what we're substituting, that's where this comes from here, right? 5 is to 2 as NP is to 3. And then to solve this, this time we're not having to flip both sides of the proportion. We're not taking the reciprocal of both sides because the thing we're trying to find is already in the numerator. That makes it easy. So we are basically just going to multiply this side by 3 and this side by 3, right? So we multiply both sides by 3, and that's what these boxes are for, to just show that you're multiplying everything by 3. It's kind of weird how they're writing it out to me. So I'd rather just do it this way, right? And then 3 divided by 3, that goes away. And then this is what I have as what NP is. You know, when you multiply a whole number and a fraction, in case you forgot, you turn your whole number into a fraction. And now we can just multiply the numerators. 3 times 5, that would be 15. And then 1 times 2, multiply your denominators, you get 2. So you can leave it as 15 halves. Or since it's an improper fraction, you can change it to a mixed number. What is 15 halves as a mixed number? Yeah, it is. It's 7.5. So 2 goes into 15 7 times evenly. Then your denominator stays the same. And the remainder, when you divide 2 into 15, it goes in 14 times. There's a remainder of 1, so that becomes your numerator, 7.5. And so that means right here, this side here is 7.5. You know, check to make sure this makes some sort of sense, right? This side's 2, this side's 5, this side's 3, this side's 7.5. That seems reasonable, all right? So that's how you do these. When you have the 2 parallel segments, where one of those segments is the base of a triangle or a side of a triangle, then it creates this proportionality, right? Where you can set up a proportion. 5 is to 2 as 7.5 is to 3. Or whatever the unknown is what you would then solve for. And so that's what you're going to practice on the next slide. And I'm going to leave this up because some of you may not be done copying that. And I'm going to reopen. I'm going to put you on student pace mode. So let me find where I put it. It's not there. It's not there. Nope. Yep. Oh, there it is. I have it in here. So I'm going to put you on to the next slide, unless you need to go back, but I'm putting you on student pace mode, which means if you aren't done and you want to go back, you can. Okay, so you can go to any slide you want to go to. Oh, and there you go. I don't know why it's so blue. Stop being so blue. What did I do? Why is it so blue? Oh my gosh. There, now it's gone. So weird. All right. So you guys finish copying this, and then I want you to try these problems. Okay. You can always, you know, color code them because they're draw all over the slide type problems. I'm going to give you some time to work on these. Let's say until 11:30. Okay, so you have until 11:30 to work on these 2 problems. Oh my goodness, I cannot type today. I'm usually a really fast typer. I don't know what's going on. 11:30. Okay. So you're doing this. Work on slide 5, numbers 5 and 6 until 11:30. Yeah, Garen, go ahead. You guys don't even have to ask. You can just go. If you're worried that like I'll be like you're non-responsive, then just I'd probably, I don't know. I wouldn't say I'm so confused. Okay. So you want to do some, I can help you guys set this up. Is anyone still using this picture of slide 4? I can go forward so I can show you how to set this up. Let's do this. Okay, so how do we start? You have a triangle, EFG. One side of the triangle is parallel to a segment. Same thing over here. You have a triangle, MPN, where one side of the triangle is parallel to a segment that intersects the other two sides. For both of these, we are able to use the triangle proportionality theorem. And how did I do that? Right here. Okay. So you have to set up a proportion. So I'd probably start with a proportion. So that means you're going to have a, it's changing colors. Okay. A ratio is equal to another ratio, right? And we're doing some color coding, right? So if you pick 4 colors, it doesn't really matter. It's going to be this piece is proportional to this piece, and this piece is proportional to this piece. Okay, so this is going to be a green number. No, green, blue, purple, pink. Okay, so I just put squiggles here because you're going to put those numbers there, 32, 24, 40, unknown, and then you got to solve it. Okay, and you could think of this the same way. I'll use the same colors. Right, so green, blue, purple, and pink. Because it's always the two sides that are not one of the parallel sides that are getting divided into proportional segments. Okay. So hopefully that helps you kind of figure out what the heck I was talking about. So you're going to try those two until 11:30, a couple more minutes. So a couple more minutes, maybe just work on the first one. All right, because like reality and time wise here. have 11 of you already trying it, so that's great. You're done. Okay, cool. Did you try both of them or just one of them? I'm just curious. Okay, awesome. To me, when I do math, like color coding helps me understand and see what I'm supposed to do. Like, so much easier than just trying to do it without color. I don't know. I'm like a very visual learner. Class done or still in session? We're still in session. So it's 11:30. So we're just going to go over the answer to these now because our class goes until 11:40. So that gives us some time to review the correct answers. Let's see what some of us came up with. All right. And so so 32 to 24 is 42 are unknown. This is our DG here. So that's set up correctly as long as this is DG. 32 to 24, you accidentally flipped your reciprocal here. It should be 40 in the top and then DG in the bottom. So for right now, I'm just looking at number 5. Okay. 24 is 2. 32 is DG just for it. So now if you flip both sides, you're good. You can do that. You can flip both sides. And you even start by setting it up that way, like this person did here. So this is cool. So if you kind of like think ahead of time, like, oh, well, this is going to be in the denominator and I don't want to deal with that, you know, you can flip it when you're plugging it in. And that's what they did. So it's true. 24 is to 32 as this unknown is to 40. And that's what they did. And then they solved and they're correct. It is 30. It is absolutely 30. This is the correct work here. Okay. 30. Ooh, look at that, cross multiplication. My favorite. And they did the same thing. They put 24 to 32 is 40 to DG. So you would flip both sides, you know, if you're thinking of it that way. So yeah, I really like these two responses for, oh, it's not letting me show them both at once. It's like, no, you can't. So we're going to go with these two, which are great for the first two. Let me see how they did the other one. Oh, they did it perfect. Nice. So there you go. This person got them both correct. Good job, person. That's, okay. Sure thing, Destiny. That's fine. You can go. I understand. And then, yeah, so they did PQ is 2QM as RN is in MR. So as long as you're consistent when you set up your proportion, there's not only like one way to set it up. You just have to be consistent like they are here. And then cross multiply. And then, yeah, perfect. That's awesome. I don't even have to do it because look, they did it. And this person did it too with color. So yeah, I'm happy with this. What you're gonna do, I'm gonna stop recording. I'm gonna do that. Okay, so technically